All right, in the second portion of our video here, I'm actually going to help you guys create a histogram. So the example we're given here in the U.S., many states have a minimum wage of $7.25. Here are the wages needed to afford a two-bedroom apartment in those states. So here's my minimum wage, $7.25. But if I actually just want to rent a two-bedroom apartment, you'll see that the majority of these values look like they fall between $14 and $24 to actually afford that here in the U.S. So while that might be the minimum wage, you almost need double the minimum wage to afford that two-bedroom apartment. So let's go through and tally up a couple of things here. The first thing that's going to be important to us is the frequency. So our hourly minimum wage is what you find across the bottom. You notice that amount is measured in dollars. Here's our number of states in which that frequency occurs. So when we have $16.32, that's going to fall in the 16 to 18 category. 1546, I'm just going to make a tally here for each frequency in the category that it falls. I'm going to cross them out as I go to ensure that we don't miss anything. But $19.23, well, that falls between $18 and $20. So it's important for us to count the frequencies. That's going to tell us how high each bar is going to go on our chart. $17.67, $15.93, total of 5. Couple more here, $17.30, not $17.38, $17.30. See what I did there? $17.09, it's going to fall there. $20.90, $23.64, $16.59, $19.83, and $17.15. So between $14 and $16, right? This is our range. So between that $2 range of $14 and $16, you'll see that down below. The frequency of 5. So our bar chart, our histogram, our bar needs to cover a total of 5 boxes, and that falls between 14 and 16. We're showing a range that we're covering. It's not specific values here, right? It's not exactly $15 in 8 different states. It's between 14 and 16. We're giving an interval. So 16 to 18, it's going to be our next bar. It's going to be a total of 10 states. I've got 10 tallies because my frequency came out to be 10. 18 to 20 is the next bar. There's only 3 of those. So that bar goes up to 3, covering from 18 to 20. 20 to 21, even smaller. There's 20 to 22. There's 1 bar. And then our final one here, we have 22 to 24. That box, that range covers a total of $2. So really the biggest difference between the histograms that we're creating today and our charts, our dot plots from yesterday. Dot plots, you'll see those fall on specific values. Those values are specific. We're counting the number of times a value is repeated in a data set. Here, we're counting the number of times a data point is represented, but we're looking between an interval. So a little less specific, and we're using a bar chart. So we're going to draw a line now to match each histogram to the dot plot. They can work for the same data set. You'll see that, I guess here in number 1, we've got a lot of things that are all kind of pushed out towards the 40 and 65 set. We can eliminate A. You'll see the majority of the data falls between 10 and 40. Option B, you'll see a lot of the data falls between 40 and 70. That looks very similar. A lot of dots, all falling between 45 and 65. We'll look at where the majority of that data falls. So we know that for B, the line that we're going to draw there is going to be to option 1. Both sets of values, doesn't matter whether we're measuring intervals or specific values, are all pushed to the far right, closer out between 40 and 70. Take a look at letter A. Where's that one going to fall? It looks like the majority of our data is between 10 and 40. That would be to option 2. C, we have a very wide spread. And that's going to fit our data here in option 3. We've got data falling all the way from less than 5 stretched out there to positive 70. So that's how we can match up those dot plots with our histograms. I'm going to let you guys fill out the rest of the information here. I'm going to pause the video, and then it's going to show you the solutions here in just a moment. All right, I filled out the last part of our notes here. I'll talk you through them. A total of 9 sharks were measured. Going across the bottom, that's our length in feet. Going up, vertical, that's going to be number of sharks. So when it says 9 sharks measured, well, when you take a look at 14.5 to 15, there's 10 sharks, 10 sharks, 9 sharks, 10 sharks. Way more than 9 sharks were measured. That would have only been in one of those bars. That would have been 9 sharks. So there were clearly more than 9 sharks measured. We're adding up the total of all of these bars in terms of their vertical height. That'd be the number of sharks. 2 of the sharks are less than 14 feet. 1 shark, 2 shark. What's everything to the left of 14? These 2 bars both go up to 1. That would be a total of 2 sharks. That would be true. Typical shark says it's 14.5 to 16.5 feet. Well, let's think about where the majority of our data falls. We take a look at our biggest bars. We have 10 sharks, 10 sharks, 9 sharks, 10 sharks. That ranges from 14.5 to 16.5. As we get further out, those number of sharks decreases quite dramatically. So yes, I'd say the average is between 14.5 to 16.5 feet long. The longest shark measured was 10 feet. Well, if we take a look at the bottom, lengths in feet, it doesn't even go to 10 feet. The smallest shark measured would have been somewhere between 13 and 13.5 feet. Hopefully today's notes have given you enough to help you out. You have a Desmos activity and an IXL to complete today. Thank you.